etc. Okay, so next up is Paul. Paul's going to talk about, actually, what is it called?
What's coming in?
What's coming in CloudStack? So Paul's actually a special, really a special guest. I work with Paul, but it's not because of that. Paul is that's no reason to be a special guest. So Paul's actually the current VP of the Apache CloudStack project. So the project has a management committee that's selected by the community, and on top of that management committee sits a VP who speaks directly to the Apache board. So the most important person in CloudStack around the world is about to do a talk for you. So give Paul a nice warm welcome.
Yeah, thank you. As Giles says, my normal day job is VP of Technology for ShapeBlue, and what we do is work with CloudStack. And because, as we've said, that it's all about individual contributions, so separately as an individual, I'm now the chair or VP of CloudStack, depending on who you ask. I guess we should probably, because we haven't really explained it, what ShapeBlue we do, the reason we're here and with talking about CloudStack is just kind of what we do. That's the absolute core of the business proposition. That's probably enough about that at this stage. I do mainly stuff around CloudStack. I do have to say that I am talking here as just a person who does stuff with CloudStack, not as my role as the VP of the Apache CloudStack, so I'm not talking on behalf of the Apache Foundation. A few people have got themselves into difficulty by making a statement and then it being quoted as Apache says, so it's not fake news, but don't believe everything I say. We'll skip through customers and stuff. It's not interesting. You can go back and look at them if you really want to. So I'll start off with my introduction into what we're talking about here, which is going to be what's coming in CloudStack. So at the moment, and hopefully by the end of this month, we will have the current LTS branch, the 4.11 branch, will have a new release of that with a number of, what's the other word for bug fixes? Enhancements of features. And that's all we do in those branches is as people report the odd little tiny mistake, we fix them and keep that going for a number of years. The next LTS branch will be that 4.13, and we're looking to be releasing that July, August this year. So we start the process of battening it down the hatches at the beginning of July, and over that following couple of months, we stop people being allowed to put new features in, and we make sure everything we've got works great. And then we try and aim for maybe every 6 months or more for versions to come out. So we'll aim for the end of this year for what would be up this 4.14, the next version. It's all subject to change and someone deciding actually we've got so much new, we need to do a release quicker, or something that everyone wants will take a bit longer and we might push it back a bit. But that's kind of what, as a community, we're probably going to aim for. So I'll do my disclaimer. So because it's a community and a whole load of basically individuals, no one individually can speak for the community. So I'm not giving you here the community roadmap and saying, it doesn't matter what anyone else says, this is what's happening. This is going to be some of the features that I know about that are interesting and maybe interesting to you that we're going to be adding into CloudStack as a community. So that's that kind of bit out of the way. So in the next major release, which we hope will be in the next couple of months, we've got some of these items, and I'll go into the first ones in a bit more detail. As I'm not going into these, you can see DPDK is something that we've been working with for 6 months or so now in KVM. So where we're talking about the DPDK being the fastest way to move packets around in the networking stack. First of all, we added support for DPDK. Then we added it being able to be put into the service offerings. We've now added that you'll be able to live migrate VMs between hosts that support DPDK. And so sort of it gathers momentum of being a fully featured thing where basically you can start just almost out of the box from a CloudStack point of view, do this. Obviously, you've got to get your hosts to be compatible as well, but that's that side. Uploading multi-disc OVAs, and I'll look a bit at multi-disc OVA, or some reasons for that in a bit, but we're making it so we've got this concept of being able to upload it from your browser, and so we've added multi-discs into that, and also added being able to upload ISOs from your browser straight into CloudStack. Before it was a slightly complex thing. So now I'll go back to the top of this list of the things we've got coming imminently. And the first one here is the idea of constrained custom offerings. The reason being is before we had the idea of a custom offering where basically instead of in our compute offering, which is the kind of blueprint for what a description would look like, and if you're used to AWS, you see the XL, the SXL, MM3C somethings. So you can create these in CloudStack, but what we said is a lot of people say, well, I want to say exactly what I want when I build it. I don't necessarily want to go to a pre-prepared, or if you're the people running the cloud, you don't want to have to make up an offering for every single permutation someone might want. So instead, we have this custom offering. But the problem there is that people could put in 200 cores, and good luck trying to get that to work, or a terabyte of RAM, or something, and you're going to have either a problem with the virtual machine actually running on the physical host, or CloudStack saying, actually, I can't do that, go away. So we've added in the idea of a constraint where we can specify as part of that compute offering what the minimums and maximums actually need to sit in. And then when the user comes along and wants to use it, they can then use their slider within those bounds. You can obviously go a step further by having multiple offerings and say, okay, for these customers, it can be between these bounds. For these customers, maybe they're on a different way of paying, so you kind of trust they're going to pay for it. We'll let you go up to 64 cores, say, and a maximum certain amount of RAM. So you can have different offerings for different customers, but still give them flexibility, which you couldn't do before. We also have this thing, Maria talked about being able to bill people and transparency in the usage. But sometimes you might create a network. Let's say if you're doing managed services with backups or some kind of monitoring solution, and you're going to have people's virtual machines connected to that network. It's a bit harsh then to start charging them for all the bits and bytes going backwards and forwards over the network and the fact that they've got an IP address on that network. So what we've added is the ability to basically not charge for that, so that you can create a service network. However much data goes over it is kind of not important. It's just a network that now exists. You can only create this if you're an admin, so the users can't start creating networks that they don't get billed for. But it enables to then have these kind of service networks where the user doesn't look at their bill and go, yeah, why am I paying for this network? This is not my problem. I already pay you for my backup as a service. Why am I paying for the network as well? So that makes that part of running the cloud that bit easier. I spoke about the multi-disc OVA and why that's a kind of important thing to us. You got two uses. Obviously, people do create virtual machines that have their root disk and a load of data disks, and they might export them. You take the VMware example as an OVA, and then they want to bring them into CloudStack. And before, we didn't support kind of multiple disks. We just said the root disk is your template. That's the end of it. Now we've started supporting actually having those multiple disks. What then gets interesting, actually if I flip forward a slide, is appliances like these, where you might want to put those into your cloud. Now these are a double whammy for us because they normally have multiple disks set up, so you need to import multiple disks to use them. But they also, if I go back, have this kind of extra data, which it's going to ask you when you deploy it. And so if you were to take one of those templates, the Juniper SRX, try and just deploy it using CloudStack, you wouldn't have been asked all of these questions, it would have just deployed it, and then it would have sat there going, well, I don't really know what to do because no one's told me any of this information that was supposed to be passed through. So what we've done is take those things on the left-hand side that would have been asked, that are in the manifest, if you like, of the OVA file that says what this thing is that you're importing, and then expose them and say, well, these are the questions, these are the potential answers, and we'll just expose those so you can now fill those in and then use those kind of appliances, which then, as I say, becomes very powerful because it makes it possible for people to just drop in these kind of network appliances into their networks. Obviously there you've got WAN accelerators, routers, but they could be VPN devices. So you put in your own VPN device just straight into CloudStack. There are so many physical devices now have appliances, and this enables people to just use those and consume those the way they were meant to be used by the original developers. An interesting one here, which you weren't able to do before, is scoping to things like zones. So before, it was a kind of a wide open thing, that if you had a compute offering, in this case, it needed to be available in every zone, because otherwise someone would try and use it in this zone, in this availability zone, as it were, and it might not work because you didn't have any hosts capable of doing this, for instance. Maybe it's one where you've actually said there are going to be 40 cores, but you only have 40 core servers in one of your data centers. So now, what this enables us to do is to start off by saying, actually, this 40 core compute offering is only available in this zone, or these zones, so that things don't break when someone tries to deploy that somewhere else. And we've done this across compute offerings, disk offerings, and network offerings as well. So whatever, maybe it's an SDN technology in terms of networks, and you've only rolled that out to one zone. Again, you've put your new StorPool servers, which run so much faster than the old stuff you had, but they're only available in one zone. So you say, right, well, that's the zone that we will scope this to, because this other zone can't use it, because it's not there yet. So this gives a lot more kind of flexibility around what you can do. You don't have to have everything everywhere to be able to offer it at all. A simple but effective thing here is people like tagging things these days. Key value pairs are ubiquitous. You don't think you can, well, I can't read it, so I'm sure you can't. Hidden away in here is a couple of tags that have been gone with this recurring snapshot. So we've got a snapshot that's happening on, that is a daily basis. The snapshot's happening every day. But you want to keep track of it rather than just having a whole load of snapshots in a big pool when you go and say, where's my snapshot? So you gave it a tag, and it says server tag, it says daily snapshot there. So now when that snapshot job runs every day, it automatically attaches the tag that you associated with the recurring snapshot to each individual snapshot to make it much easier to find later on. So you can see, oh, well, here's my snapshot, and it was of this type. And that's been inherited from the thing that set it off in the first place. Some of them are kind of think, oh, why didn't we think of that before? But the hindsight is always great fun. And then we've expanded on quite a few things. Externalized branding. So you can see here I had a bit of a play. What's particularly interesting about this is it's got multi-language support. So if you go behind the scenes in CloudStack, there's a whole load of files which have the kind of, here we've got the label of the app name, and then we have it in English. But I think there are about 13 different languages that are fully translated in CloudStack. So you can go to any one of these languages, which means you can have actually that tab at the top or the help menu or the about box in whatever language you want it translated to. So the tab at the top can be different in Japanese to French to English, but so can the help and whatever. So all of those things now, we've made it easy to get in and change. Before you had to go in and actually change bits of code in the JavaScript. It was possible, but a pain in the neck. Now we've pulled it out and made it easy to then be multilingual as well. This is an interesting one because it was tucked away in the API until someone talked about should it be in the UI. A lot of people, including myself, didn't even notice it was there. It was hidden away with a weird name. So it didn't. It was how to share templates, but it was called, the API was called Update Template Permissions, and one assumed that just updated the permissions on it, not started sharing it to other people. So then we started digging around and found out what that means. So in a normal public cloud, you don't want one set of users to know what the other set of users are, who they are. You certainly don't want them to be able to look and see, oh, look, here's all the other accounts that are on this CloudStack, and see all the customers. So in, if you like, normal configuration, you have to know the IDs of the accounts or projects that you're going to want to share with first. So you would have to go to the other account, someone you actually know, and say, what is the UUID, which is, God knows, 32-character string. There's no way you're going to guess it. They tell you, and you can say, oh, okay, well, now I can share my template with you. In a private cloud, you may all be friends and trust each other, and actually your different accounts are just different departments. And the fact that there's an accounts department is hardly a secret. In that case, that we have a different setting you can use where the list of accounts you can add will actually be listed. And then to make life easier for you, you just select, oh, I want that one, and that one to share my template with. So we can add accounts or projects that you want to share with. We can remove them, or we can just reset it back to not shared with anyone. So it was always there since we can, as far back as our kind of records go, as an API, but now it's visible. People can realize it's actually there. So that's what we're looking for, or looking forward to, in the next couple of months. So that's all either already in the kind of master code base or sitting, waiting to be merged in there. So that's all stuff that's pretty imminent. And now I'll look at stuff going forward in more 6 months of things that are in the pipeline, that are in development, that are quite interesting. And I'll cover these off. We've got our backup and recovery, some KVM maintenance things, and the idea of health checks on the virtual router. That's not the order I was expecting. So starting off, KVM Rolling Maintenance. So we have, and we know of various customers who run large KVM estates into the thousands and thousands of hosts. And maintaining those is a bit of a pain in the neck. And certainly some of them have loads of scripts and stuff they have to run individually and work out, okay, well, I'm going to take all the virtual machines off this host, put them on that host. Now I can do my maintenance and wait till it's finished, go and check, okay, now I can move them. And it's very manual, and it's complicated and very time-consuming. The idea here is that we would select either a whole zone or a pod or a cluster, and then on a per-cluster basis in that scope, start doing the maintenance for the user. So the admins are supplying us with the scripts, the patches of the whatever they look like, probably bash scripts or something, or maybe some Python. And they put them on the hosts. So those, getting them there is down to the admin, so that they can trust what's there because they put it there. So we're not getting involved in that kind of security piece or the worries of that. Next, you tell CloudStack basically where the scripts are and go do. It will, there's loads of layers of what it's going to do, but it's going to check that all the prerequisites to doing a rolling maintenance are okay. are the hosts actually up? Can I talk to them? Do I have enough capacity to take all the VMs off one host and put them on the other hosts and do this work? Because if I don't have capacity to do that, this is all going to fall apart very quickly. And if we find we can't, we just won't even try. We enable running of what we call kind of pre-flight checks on the hosts. So people may have their own tests, their own checks they want to do on every particular host before they start doing this. Do I have enough disk space, for instance? Well, we wouldn't know how much enough is as CloudStack, but someone can write their script, and if it returns an error, then we stop and go, no, can't do it, not enough space. So we run those, then we say, right, we're going to migrate everything off for you. We will run this script you've told us. When your script comes back and says it's finished, we will put this host back into the cluster, or back enabled, and migrate everything off the next host, and carry on like that, going one by one until we've finished the cluster. So we're just automating that and making CloudStack aware, basically, of what's going on. So it knows to disable the cluster while it's doing it, and just basically knows what's going on and where things need to go. So that, hopefully, will be very helpful for those people who are trying to manage large KVM estates. Because it's not, how do you describe it, an enterprise product in the same sense as, say, VMware, where there's loads of tools and stuff to do this kind of thing. It will help those kind of infrastructures enormously. KVM, I don't assume we can use the term DRS. Everyone knows what it means from a VMware sense, which is, well, distributed resource scheduling, basically working out where everything should go to try and keep everything kind of either balanced or packing hosts. So there are various reasons and algorithms that say why you might want to balance hosts and why you want to pack them. Balancing, obviously, in theory, will give you a nice, steady performance across all hosts, because none of them are particularly full, none of them are left empty, and you've got a nice balance. Other people may want to pack their hosts because they could shut down hosts that weren't needed, so save power and cooling. Or because if you balance all your hosts, you do actually make it difficult to put one big virtual machine in. So if you pack everything down one end of your storage, and one end of your compute, and then come up with this big VM, there's now a space, and that's the bit that isn't being used. Whereas if you balance it, this big VM will have nowhere to go because no individual host will be able to take it. So it depends on workloads as to which is most useful for you. So what we're going to do is, instead of trying to calculate where every VM, where the optimal place for every virtual machine should go is, because that's a big old mathematical calculation, we do a kind of cost-benefit analysis and say, right, very quickly, which VM should I move to try and make this better? So this host is really busy. This host is not so busy, or not very busy compared to all the rest. If I take one from there and put it there, things are better. And that's I get the most bang for my buck of a move for doing that. And I set a threshold to say, I want all hosts to be within, let's say, 10% of each other. So there's a band of about 10%. And I look at that and go, right, how am I doing now? And you go, okay, well, this host is still got 15% more than the average, and this one's got 20% less than the average. And okay, right, I'll take one from that one and stick it down there. Now look at my scenario, what's going on now. So we do it as just an iterative process where we're just looking at what is the state now and what can I do most effectively to right at this moment. Because, you know, even if we try to do all the calculations of where everything should go, if someone else turns up and starts in a couple of more VMs, our kind of calculation's gone out the window anyway. So there's no point in trying to guess where everything's going to go, because it might not work when we try and do it because this great big hefty VM turned up. So what we're trying to do here is do a simplified version where we say, okay, off you go, try and get this all balanced. Now this kind of segues back very nicely into the previous feature, because when you think about it, at the end of doing all this maintenance, you're going to end up with a host you've just returned to service with no virtual machines on it. And somehow, you probably want to balance that all up again. So, queue new feature, which then can run at the end of that patching process, to then say, okay, well, I can take a bit from each one of these, put it over here, and now I don't have a host sitting there doing nothing while all the others are running hot. So, as well as having a purpose of its own of balancing hosts, it also has a very specific use after doing the rolling maintenance as well. So they fit nicely together. I think we're going to be very quick here. VR health checks. The virtual router can have issues from time to time. And so what we think, or thought it would be very helpful to do, is have it actually do some sanity checks. Check on itself as to what things are going on. So we at least were sensible about this, hopefully, and thought, well, we don't want the management server. We know people with thousands and thousands of virtual routers in their estate. So we don't want the management server constantly pinging every single one of these saying, hey, guys, how's your disk looking? How's your network looking? It's going to be so much traffic, it'd be ridiculous. So what we've decided, we'd have the virtual router doing a whole load of checks itself periodically, say once an hour, for instance. Then maybe once an hour, the management server would ping the VR and say, did you run your health checks? Okay, great. What was the result? And you've got two things here. Either, no, I didn't run them. Okay, well, something's wrong. Or, yes, I did, and there was a problem, or yes, I did, and everything's great. So you then get, for less load on your management server, what's going on in these virtual routers. We're taking it a step further. We then go, okay, well, let's have some thresholds here. How many times does pinging your gateway, for instance, how many times should that fail before we start raising an alarm and alerting people and getting people out of bed? And we'll make those configurable so people can say, well, I'm not bothered about it, or actually I want to know straight away. And then on from those, there are some things you might want to do where you say, okay, well, if this happens, I want you to just restart yourself. Just shut yourself down, restart, and hopefully the problem will go away. Obviously, again, that needs to be configurable because, for instance, say there is a tiny network outage on a switch or something as a blip. You don't want every virtual router you've got suddenly rebooting itself because of that little blip. You need some kind of, it's self-checking. Oh, okay, well, it seems okay now, I'm not going to do it. Or actually, I won't reboot myself if the pings aren't coming back, because that probably means a network problem and not a problem with the virtual router. So you will configure what check justifies the virtual router restarting itself if need be. And here are some, probably most of the kind of checks we're going to do. It's just the basic one. Can management server talk to the virtual router? Which obviously we'd get an error if we couldn't anyway. But then the virtual router talking to its interfaces. Free disk space, for instance, CPU memory usage. If they're nailed to the ceiling for an extended period of time, there's probably something going wrong in there, and it's probably not going to respond and update and do what it's supposed to do very well. Basic sanity checks on a lot of the services. Are they just running, for instance? Configuration checks where you've got services like DNS and DHCP and all the IP tables for the routing and what have you. Does what they're set up to do match what we thought it was supposed to? Have they got out of sync in some way? Has something weird happened? All of these things that will let the virtual router sit and do itself, and then be polled by the management server to say, yeah, everything's great, or not quite sure about this. There's something needs looking at. So basically the operator of the cloud finds out what's going on before the user phones up and says, my network's not working, or I can't get to the internet, or my virtual machines won't talk to each other. We have the ability to know that before they call rather than afterwards, and also potentially do something about it. The kind of big one that almost gets its own little drum roll, and it gets its own title, is backup and recovery. And I'll go into the why of that first. So we do snapshots at the moment, and the problem with people doing snapshots, in order to save their data for it to be a backup, is that you have to do them each disk separately. So it's not a crash consistent snapshot you've got. In fact, in some hypervisors, you can't do one disk while the other disk is being done, which means there could be an hour's difference between, let's take an Exchange server with the OS, the logs, and the actual data, each one an hour apart. Well, good luck trying to restore that and expecting anything to work afterwards. So you end up with the baby with the big head and the man with the little baby head and going, what's going on here? This isn't consistent. This is not what happened. So even when you've got Zen tools or VMware tools installed, they might be able to help out by trying to quiesce the operating system a bit. But once you're going across multiple disks, nothing's going to save you. Your transaction logs are going to be way out compared to your database. There's also the problem that, as everyone's probably found out when doing them, they can be slow. The time it takes to transfer, I mean, you've got basically the laws of physics at play here. You've got however many terabytes of data on primary storage, everybody setting their backup to happen at 1 a.m., and then all that data has got to be moved. There's no getting away around that. That's what they've done. And also, then you've got lockouts while that's happening. So someone can't stop their VM or can't do various things, can't move their virtual machine while that snapshot's running. So if people have terabyte disks, this is going to take a while. And so, but this is what people have had. This is the only real option directly from CloudStack. And another bit is then trying to get it back again is somewhat of a nightmare, because you have all these multiple steps, particularly if you're trying to restore something from that was a snapshot and then want to make it into a virtual machine again. You've got the data going backwards and forwards multiple times to various places. And even then, things like MAC addresses will be different because it's actually a new instance. There's various things that mean it isn't actually the VM you backed up that you get back. So, what are we going to do about it? So, our backup and recovery thing, largely we call a framework. And the reason for that is it is essentially agnostic of what the backup software that's being used is. And we'll come on to the particular vendor that we spent some time working with to develop a plugin, so there was something useful there. But the way it's been developed, the idea is that CloudStack has, if you like, one name, one API to do things with. It has the idea of a backup. It has the idea of scheduled backups, ad hoc backups. I'm going to come into backup policies, which I'll explain a bit about. It's kind of a new way of looking at backups. Restoration, all the kind of usage of it. It's all one API. It doesn't matter from the end user perspective what that is. It's all abstracted in the same way as we abstract the hypervisor. So we get all of the features that we'd expect then from proper backup. Restoration in place of a virtual machine. Restoring a virtual machine and making it the data disk of another virtual machine so that you can just open it and get data out, that kind of thing. I'll explain what you see down here, our policy-based backups. The idea behind that is a particular backup vendor that is kind of pushing this particularly.
It says it up there.
No, they're not the people who kind of coined it and started driving this idea of not doing them all at the same time. So the idea with a policy, as you can see here, is maybe gold, silver, and bronze with 6 hours, 24 hours, 7 days. So you say, right, I want to make sure I never lose more than 6 hours of data. I want to make sure I never lose more than a day. I don't want to lose more than a week. From that point of view, it doesn't matter when this happens. That's not what you've said. It's not a schedule. It's not saying the backup will happen at midnight, 6 a.m., midday, 6 p.m., midnight. It's not saying that. It's saying there will be 6 hours in between each one. With that, the person or the provider of the backup can start staggering them. They don't need to all happen at the same time. You start working out, actually, if I do this one now and I'll do that one then and that one then, I can keep a nice steady flow, not the massive peaky thing where everyone starts them off at, what's the earliest everyone does, 11 o'clock maybe, and then they always try and stop by 5. So you've got this window that normally every backup happens. It gets sort of completely away from that idea and instead just says, this is the policy that you will only lose up to 24 hours, up to 6 hours, up to whatever. So that is the policy-based backups. Now we move back to the particular company that we were working with, Veam, with their version 9.5, I think it is. And because we have this idea of policy, we then map that through the plugin driver type idea, that now we find a way for Veam to do that. And whoever else who can provide that functionality, that would then do the same thing. But the user, the person backing up the VM, doesn't need to know who's doing it and what that back-end software is. So that gives us these backup policies, which are completely linked. So CloudStack knows about these, but then titles are just purely in CloudStack. Names. And again, we have our ad hoc and scheduled backups, which are much more in line with the normal things you do with a snapshot. You do them just because I want one now, or I want several. We will make sure that they are unified. So if you've got a schedule that runs every, say, once a day, and now you're about to do something and you want to say, well, actually, I want to back up just now, you want that part of your backup chain. You don't want it to be a separate backup here, because that completely breaks all your chain of going back over time of that VM. So they'll be driven together so that your ad hoc backups are still within the same chain if you're doing incremental backups as the scheduled ones. And again, as I say, all of this is transparent to the end user. They just see what it is they're going to do. They don't need to know the stuff that's going on behind the scenes. Ooh, that was quick. Any more to say about that? And that, yeah, as I say, it doesn't have to be Veam. We've written the plugins for Veam and for just a kind of stubbed for testing at the moment. There are various other people who are kind of interested. I think they're all waiting to see what it looks like to then dive in. But the API side of it is all written. And I think there might even be a pull request I thought I saw knocking around somewhere. For the API side, we are now just doing the UI side of that to match up. So that's all very much in progress and going ahead. So, yeah, that works. So yes, I can take questions now on any of those. Anything non-technical, please ask Maria. But other than that, that's a kind of view of just some, and I really can only stress this is just some. It's probably a fraction of what's going on in various parts of the CloudStack world with people developing things. Certainly, the people working with Ceph will be upgrading and updating what that can do. Obviously, the StorPool guys will have developments they've got coming with their plugin and how that works with CloudStack, or even developments in CloudStack itself that they say, oh, well, that's a bit rubbish, I'll just fix that. So that's just a flavor of the kind of development that's still going on. Hopefully gives you the feel that CloudStack is alive and kicking and very much still driving forward and trying to add to what it does and keep going. Hello, yes. Does it involve KVM kernel?
Hey, so the new features that are coming in CloudStack are you going to ensure they work on all the hypervisors, because there were like Oracle, VM, and all kinds of different,
Yeah, so does it work on, will they all work on all hypervisors? So the Veam, for instance, would only work with KVM and, with VMware and Hyper-V, and there's not a lot we can do about that. If there's another vendor that then supports the other hypervisors, then for that, it's just a case of the plugin working for it. It's creating the plugin that does them and understands what it needs to do with the hypervisor to make the backup work. KVM DRS is going to work on KVM. Depending on which one, most of them, yeah. A Multidisc OVA is really only obviously a VMware feature, because they're the only guys with OVAs, and I don't think that there's any capability in KVM to receive all that extra stuff for appliances, so it just wouldn't kind of be applicable. But certainly, the vast majority of what we write is to try and be as broad as possible, and a lot of that was up in the kind of management plane rather than the IaaS plane. So it depends for the awful answer, I'm afraid.
One more. So the KVM DRS, will that look at CPU load, or will that look at allocated, just provisioned CPU?
It will be a global setting for the user to select what they want to be the arbiter of load, which could be, for my mind, it's got to be CPU, but could be memory for some people, and then could be allocated, or I think most of the time CloudStack tends to think in terms of allocated, but it will probably be either. It'll be you pick, and that will be the metric that just gets stuffed in.
So what I've seen from, there was this company that does packing of virtual machines, like a special plugin for OpenStack or something that packs virtual machines. What they were doing was definitely looking at multiple parameters, because it's like, you can think of it as being at least two-dimensional amount of memory and amount of CPU, and you may have like VMs with a lot of CPU usage and a little memory in the same hypervisor as VMs with a lot of memory and a lot of CPU, and it's more optimal than the other way around.
Yeah.
So
is that Turbo? No. Yeah, didn't they cut VM?
I'm thinking of...
Yeah, they became Turbonomics.
Yeah, that one, and I'm also thinking of Sardina systems, but they're not so popular. So my point was, would the feature in CloudStack look at multiple dimensions and try to pack in multiple dimensions, or will it look at just CPU load? Or
yeah, it would just take one dimension.
Single dimension, okay.
It was an interesting thing we looked at, actually integrating with the likes of what was VM Turbo, Turbonomics, and have that do the scheduling, decide where to put things. And if it decided load needed to move around, because their main statistic they look at, I think, is actually, funny enough, the wait queues. And that's how they say, well, it doesn't matter what any other statistic says. If there's a big queue, it's busy. If there's not, it's not. Yep. And but I think they may have found it hard to get market penetration, and if no one's using it, there's no point CloudStack supporting it. But yeah, from ours, it'll be simple DRS, so we just take you pick your metric, and that's the one we'll use.
The actual usage is problematic because it's changing over time, so you could end up being, doing DRS executing all day long.
It would make using allocated a safer bet.
Exactly. Yeah.
But when you take load over, you'd probably have to. You start getting into needing to take some averages of load, which starts complicating things.
So I want to ask about the backups. What you have is a framework for integrating different backup solutions, or what is it?
Yes, so if you split it into two parts, it's the framework itself, so CloudStack having the APIs and the UI and the database and everything to store the information about backups of VMs and store them as first-class citizens. And then you have the plugin, which the one we've written is for Veam, which then takes, okay, you said you wanted to back this VM up now, then we know how to, this plugin knows how to actually do that. Or you said you want a schedule of backups, well, we'll use our scheduling service to keep firing that command at the right time to the back end, which happens to be Veam. So yeah, it's in two completely split parts so that any other vendor can come along and say, well, either please can you write it for us, or we'll write it ourselves, the piece to implement whatever with whatever. You could, I don't know if you do like migrating to S3 or something from StorPool. StorPool could have the equivalent of a backup plugin which says back this up, and it goes to the back end and pushes that up to S3, so it never goes out to secondary storage or anywhere else. It just it can be done. You know, obviously the storage vendors have an advantage there, because for anyone else they've got to move the data from place A to place B via the storage, whereas the storage vendor can just say, okay, well, you said you wanted it there, so there you go, I've done it.
So it discovers restore as well.
Yes. So again, the plugin needs to know physically how to do that for that software and the different hypervisors that it supports, but the framework knows the idea. It knows the idea of restoring a VM over the top of where it was, restoring a VM as a disk that you can then mount, or that you will automatically then mount into some other virtual machine to just get the data out of it, whichever you want.
Hi. I was wondering in regards to the DRS, let's say we have an example where a number of VMs should be kept on the same host. How does DRS relate? Can it be made aware of that thing, so when he moves the VMs to keep them together?
Yes. We will go through the same algorithm, same subsystem that says where VMs can go. So we have to take into account not only there's got to be on the same affinity rules, we've also got to take into account tagging, host tagging, storage tagging, all of that. We've got to make sure that that actually can go to that place and doesn't break any of the rules that are in already there. So yeah, we basically ask the same bit of code where you normally would put it, where it should go, or where it can go.
Okay, thank you. One more.
Yep.
Let's say we have an environment which is not into CloudStack. Is not. We have a hypervisor that is not managed by CloudStack, and we have VMs running on it, and we want to move them and import them in CloudStack while they're running. Is it possible?
Yeah.
Yeah, that's the word. How to adopt.
It is something that, funnily enough, is sitting on the roadmap, and various bits of things like actually restoring VMs all tie together, because in both cases we've restored a virtual machine via backup, and now CloudStack needs to know it's there and it kind of do that thing. It actually just appeared from nowhere, and now CloudStack needs to know about it and call it what it was supposed to be called. So it's on the roadmap by kind of you're saying, right, if we get to this point here with backup and recovery things, we actually have most of the work done, and makes our last step to doing that much smaller. So there are ways of doing it that are quite messy and certainly not supported in that kind of sense, but hopefully we've got coming ways to physically just do it. Yeah.
Okay, thank you.
Any more questions?
Cool. Thank you very much, everyone.